we coded for vehicle-to-barrier interaction using a scene diagram like shown here. This was just how the vehicle interacts with the barrier and what type of trajectory it redirects off the barrier at. And then we coded for impact angle, just what angle the vehicle impacts the barrier at, and then barrier impacts, whether it was a single barrier impact or multiple barrier impacts. So barrier type. These were 5 main, pretty much the majority of the cases all fell in these 5 categories. We have strong post W-beam barriers, weak post W-beam barriers, cable barriers, box beam barriers, and our typical New Jersey style concrete barrier. And we separated these into two primary categories. We got our metal barriers over here, and then we have our concrete barriers over here, which is just primarily this New Jersey shaped barrier. And the majority of the metal barriers fell into this strong post W-beam barrier, and there was too few of these other barrier cases to make separate cases for those and separate analysis for those. So for the purpose of this study, we just grouped it into these 2 basic categories. Next, we looked at our vehicle-to-barrier interaction, and this was how the vehicle interacts with the barrier and redirects off the barrier. So this is what we coded as a smooth redirection trajectory, and this is where the vehicle impacts the barrier and then continues off in its intended direction of travel. This is what we considered the ideal case earlier. And second, we have a snag, which is where the vehicle impacts the barrier and then redirects off the barrier and spins and rotates off the barrier. And another case that can be included in the snag was the sometimes it'll snag on the barrier, and then the back of the vehicle will whip around it and impact the barrier a second time. And then over here we have our penetrations, and this is where the vehicle impacts the barrier and either goes through the barrier or over the barrier. And for the purpose of this study, we excluded these penetrations because these were cases where it was obvious that the barrier malfunctioned, that it was a problem with the barrier rather than some of the other factors that occurred. So our impact angle. Impact angle was estimated based on these scene diagrams, since there was really no known impact angles in our data set, and the best we had was to look at these scene diagrams of the crashes. And we coded less than 35 degrees approximately as a low impact angle, and greater than 35 degrees as a high impact angle, as you can see here. And these cases were compared to cases from another data set, which was NCHRP Project 1722 data set, and they took NAS CDS cases and completely reconstructed the crashes, and it has a lot more information than the NAS CDS database. But the only problem with this was there was only 67 cases in which a vehicle impacted a barrier and the impact angle was known. And so we were able to compare these cases with the cases that I did, and we were able to determine that I was approximately 75% accurate in coding these for high and low, just from sight based on these scene diagrams, which is a reasonable accuracy for the information that we had. And some of the errors occurred in that mid-range where it's hard to tell whether it's a high impact angle or low impact angle. And next we looked at barrier impacts, whether it's a single impact or multiple impacts, either on the same barrier or a different barrier. As you can see here, these are our single barrier impacts, where the vehicle impacts the barrier and then whips around, and the back hits the barrier again and redirects off. This was a single impact. And then over here was vehicle impacts the barrier and then just redirects off the barrier, like more or less the ideal case. And over here is our multiple barrier impacts, where the vehicle impacts the barrier, redirects off, and hits another barrier. And then over here where the vehicle impacts the barrier, redirects off the barrier, and it has a clear clear redirection off, so there's considerable separation between the vehicle and the barrier, and it subsequently hits the same barrier a second time. So to analyze this data, we used SAS, or statistical analysis software, and we had our inputs, which are our different factors, and we used a binary logistic regression model to predict two different models. So our inputs were a barrier type, whether it's concrete or metal, our vehicle-to-barrier interaction, either snag or smooth, and impact angle, high, low, barrier impacts, single or multiple. And we also included this vehicle type, because this was vehicle type also plays an important role into whether a vehicle rolls or not. And this is something that was included in our NASCDS database. So we looked at that, and LTVs were vans, light trucks, and SUVs. So we grouped those all into one category, and then and cars as well. And so we predicted these two models: does the vehicle roll over, and is the barrier the tripping mechanism if the vehicle rolls over? So with these multiple barrier impacts, to make it simple, and so we can include these in our general study, we came up with a critical classification. And the critical classification was for vehicles that did roll and impacted two barriers after the second barrier impact. Our critical classification and what we used in our analysis was the barrier that caused the rollover, the barrier prior to the rollover, and the impact, the way the vehicle interacted with the barrier prior to the rollover. So we kind of didn't include this first impact. But for vehicles that didn't impact the two barriers and didn't roll over, we coded the most severe, what we considered was the most severe. So for vehicle-to-barrier interaction, it was snag, whether that determined on the first impact or the second impact. And for impact angle, it was high. And so whether the impact angle, the first or second impact, was a high angle. And the barrier that we used in this was the first barrier that was impacted. So here's our results. This is kind of a general layout of the data that we had. And as you can see here, the difference between rollovers and non-rollovers is pretty big. There's a considerable amount of cases where the vehicle did not roll. And you can see here concrete and metal distribution was pretty similar, and as well as the angle was pretty similar. And multiple barrier impacts, and whether the barrier impacted multiple barriers or not, was pretty low. In most cases, there was just one single impact that occurred. And then here's our weighted amount of cases, and this was just using the weights that were included in the database. You can see here the amount of crashes this would be if it was nationally, to make it nationally representative. So here's a layout of barrier tripping mechanism, and what's the tripping mechanism when a vehicle rolls. And as you can see here, for concrete barriers, it's equally as likely for the barrier to be the tripping mechanism or something else to be the tripping mechanism. And then as you can see for metal barriers, it's much more likely that something else causes the vehicle to roll rather than the barrier. So we took this other category, and we were like, and so we took this other category and laid it out to see what these other factors were and what was more likely to cause the vehicle to roll. And so here's this distribution of the other category. And we have the ground, a turnover, a fixed object, or other. And you can see here that the ground was much more likely to cause the vehicle to roll in this other category if the barrier did not cause the turnover. And fixed object, turnover, and others is pretty similar. And this other category includes cases that where the tripping mechanism was either unknown, so they couldn't determine it, or things that weren't necessarily could be classified as fixed objects that they didn't have a exact classification for. It's like another vehicle to cause a vehicle to roll over is something that would be included in this other category.